Hey everybody, Dr. Imholt back again. So today we're going to get a little more detailed into some actual sort of science and in an area where scientists, data analysts, humans in general have a tendency to make some mistakes. And it's not because we inherently are flawed, although we actually are. It's just because of the way the brain works. So, brains and math sometimes don't go hand in hand. And what I'm talking about today is pattern recognition. So we all see computer programs now that are facial recognition, recognition and different patterns in different fields. And one of the things that always drives me a little bit nuts is when economists come up and say, look, we see this pattern. Well, the trouble is a lot of the economy is driven by emotion, and a lot of it is driven by different people kind of going in different directions and, 15 different forces that come to play. And none of that actually has anything to do with a pattern. But what does any of that have to do with science? Well, it has to do with the way the brain works. So let's dig into some of those moments in time when scientists were absolutely certain they knew something because they saw it with their own eyes and it looked like a pattern. And it turned out to absolutely not be true. Some of them may surprise you, but they sure enough are very real. So let's dive in and start with Mars. Now, Mars was first seen through a telescope in 1610 by Galileo, but it really got its name from ancient Romans because of the reddish color. Other societies had different names for it, just depended on which one it was, but Mars is the one that's kind of stuck. So now this particular image of Mars is from 1909 from the Mount Wilson Observatory. This was about as good as you were going to do with photography even in 1909. So back in the 1800s, scientists were still trying to figure out this planet. So the process then was they'd look at the image through the telescope using their eye. They would try to find a time when the atmosphere was not quite as turbulent and there were no clouds, nothing, you could see it well. Then they turn around and quickly draw what they saw, using their memory. So professional scientists, including famous astronomers who'd made other discoveries that now are confirmed and celebrated, can make serious and profound errors. And what happened was in these images and in these pencil drawings for that were going around for years, you would have these canals identified. Now, what kind of canals are on Mars? Well, here's a map from the late 1800s identifying a bunch of different Martian canals. And the scientists at the time had these theories of what the canals would be used for, whether they were naturally made or man-made. Many people actually were touting them as evidence of made by intelligent beings. And they were using it to bring water from one spot to another so they could irrigate crops, or any number of reasons for these canals to have been constructed. So even up to the point where Encyclopedia Britannica was publishing things in their encyclopedia that was the best minds of the time saying, look, here we've got Mars and Mars canals, and eons ago, there must have been intelligent beings up there. And those intelligent beings must have built these because they needed a way to get water from one place to another. We do it here on Earth. Why wouldn't they do it up there? Well, that was the best images we had, and they drew conclusions based on the best possible images. Now, what happens when you get a better image? In the 1960s, NASA spent a bunch of money, put a satellite up that went to Mars and sent back a bunch of really nice pictures. It was called Mariner 9. And what that showed us was that all of those canals we thought existed really weren't canals. They certainly weren't made by anything intelligent. They are on the surface, but what we were viewing as canals were actually optical illusions brought on by topography on the surface. It wasn't actually anything made to take water from one place to another on the red planet. To our knowledge, there has never been intelligent life on that planet. There may someday be as man tries to get there, and that may occur in our lifetime. But as far as we are aware, there has never been intelligent life there, much less anything that formed a canal. So science in itself should be self-correcting. You have evidence, you draw a conclusion. Now, I would have always called the canals being made by intelligent beings a theory, because unless you can prove it, there's no way to call it anything other than that. But even that theory has now been completely disproven. Now, there's a lot of other versions of humans seeing things when there's really not anything there. So let's take another look at one of those. This is the Horsehead Nebula. It's a small dark nebula that can be seen in the constellation Orion. It's kind of in the near the easternmost star of Orion's belt, which is another pattern that people have seen in the sky that's not necessarily a pattern for anything other than we happen to kind of think it sort of looks like a drawing of Orion. Now, in this nebula, of course, people saw it and went, my gosh, that looks a lot like the head of a horse. People wanted to assign a shape to that object, whether or not that shape really exists. So let's get a little bit closer look at the Horsehead Nebula. Now, the other image you saw was from a ground-based telescope. This is the Horsehead Nebula as seen through Hubble. Much closer in, starting to lose some of its shape of a horse. So humans inevitably want to see patterns. We're comfortable with patterns. We like patterns. And as such, scientists and mathematicians have come up with many ways over the years to look for patterns in things and describe it with a math equation so that we can predict what that pattern is going to do. Let's take a little bit of a look at one from nature here on planet Earth. Now, this is an image of a sunflower here on Earth. It's not a picture of some drawing from a math equation, although it is got a very distinct pattern to it. There's a whole field of mathematics known as fractal geometry that tries to come up with ways to mathematically represent and then graph out these patterns from nature. And that has actually helped scientists find patterns in things, find patterns in apparently noisy systems. You can use those tools to solve physical problems and help find a better way to not only describe nature, but describe what's going to happen to a system if you apply an external force on it. There are hundreds of examples of scientists, mathematicians, economists, statisticians finding patterns where one doesn't exist. And they want to assign a value to it. And they want to be like, that's exactly the pattern I've seen before. And one of the reasons I wanted to do a video pointing out where our mind does see patterns in things that aren't necessarily there, even to the point where Encyclopedia Britannica is going to publish articles about canals on Mars dug by aliens. All of those are great. They just turn out to not be true. Now, a lot of times what I see on nightly news, especially when it comes to things that affect our daily lives or things that are more politically oriented, is you'll see a set of statistics and they'll come up and pop up and go, look, here's a pattern in these statistics and that hasn't been seen since over here. The trouble is in any system that's complex, whether it's the universe or nature or a broader economy or anything that's in a real world situation and not a pristine laboratory someplace, there's always external forces being applied to things. And those external forces alter the outcome of that event. Now, if you've been watching the videos I've done on the Nobel Prizes, there's one for Heisenberg about the uncertainty principle, and it has everything in the world to do with, well, if you measure something, have you altered that? Well, once you take a snapshot of something, you start to really understand it. Are you altering the outcome? And if you only pick and choose certain statistics to look at, are you trying to predict an outcome that may not come true because you haven't really looked at the complete overarching system that's going to involve the outcome of that event? So when you look at things, it's important to not have a biased eye and go, oh, I want to see this or I want to see that, because that can lead to colossal blunders like we've got, intelligent beings creating canals on Mars, or hey, that looks like a horse head when it really doesn't. Kind of does actually. But the point is that when you see these things, you need to be able to have enough tools in your tool set to be able to understand, are those statistics telling me what I think they're telling me? And can I make a decision on that? Or is there more to this story? And are other forces going to come in to alter this complex system and have me not really see the outcome that I want? And that, I think, is something that's very important to the world around us and where science and mathematics can really help. But not if you're trying to do science and mathematics based on some idealized set of circumstances that preclude a lot of pertinent information and pertinent forces applying to that overarching system. You've got to think big picture. You can't think, oh, I'm only going to look at, this and this and this, when really there's 17 things that apply. So I do hope this was interesting to you, and I do hope you click subscribe and like, and we'll see you on the next video.